prove that for all A and B belonging to the set of integers where B is not equal to 0, if A divides B, then the absolute value of A is less than or equal to the absolute value of B. Okay, so to prove this, let's establish the fact. Suppose A and B are integers and B is not equal to 0. We prove that if A divides B, then absolute A is less or equal to absolute B. Alright. So the point is that A and B must be integers. That's the only condition for which we can say that the absolute value of A is less than or equal to the absolute value of B. Before we prove that, let's talk a little about divisibility of integers. Alright, so when I say an integer, so if A and B belong to the set of integers, which is written this way, then A divides B if and only if, we write that in math this way, if and only if there exists, it's written in math this way, if and only if there exists an integer k, that is a k belonging to the set of integers, such that, this is how to write such that in math, B is equal to k times A. Let me make this point clear. So if A divides B, what it means, let's use numbers. Suppose we know 2 divides 6. What it means is that 6 can be written as an integer multiple of 2. So if 2 divides 6, then there should be a k belonging to Z, because 2 and 6 are also integers. So the k that we are looking out for should also be an integer, such that there should be a k belonging to the integers, such that 6 is equal to that integer times 2. And of course, we know that the only integer that multiplies 2 to get 6 is what? 3. So k is 3. Of course, 3 is an integer. So the point is that if an integer A divides B, then B must be written as an integer multiple of A. And that's it. So in this problem, we are given that A divides B. Already we know they are integers, so there's no need to continue saying that. Given that A divides B, based on the definition of divisibility, B then is equal to k, some k times A, where k must be an integer. Yes, so it is established, or it's an established fact that k is an integer, and so we can write this. Now, I'm going to take the absolute value of both sides of this. So taking absolute values of both sides. I'm going to get the absolute value of B to be equal to the absolute value of Ka. Let me say this is equation 1. Then I can write that the absolute value of B is equal to the absolute value of K times the absolute value of A. This is a property of absolute values. Now, there's a product, so when you find the absolute value of a product of two integers, it is also equal to the absolute value of it's also equal to the product of the absolute values of the integers, of the numbers. So that's one property of absolute values that we must take very good note of. Now, at this point, I'll name that equation 2. Now, the point is that, so since we are told that B is not equal to 0, since B is not equal to 0, the absolute value of K is always greater than or equal to 1, of course. K is an integer. If B, look at from this equation, if B were to be equal to 0, what it will mean is that K is automatically 0. Because if we divide through this equation by A, where B is actually 0, 0 over A will then be equal to 0. But then we are told B is not equal to 0. So what happens is that the absolute value of K will definitely be greater than or equal to 1. Don't forget, the absolute value of a number makes the number positive, because K is an integer, and the least integer that is not 0 is 1. Therefore, K must either be 1 or more, since B is not 0. Good. Now, from this, K is greater than or equal to 1. I'm going to multiply. Let me say this is an inequality. I'm naming it 3. Multiplying 3. It's not an equation. The inequality 3 by absolute value of A. Because I can trace absolute value of A here. So I just want to establish some fact here. So let me say I just want to multiply through both the left and right hand sides of this inequality by absolute value of A. That gives me absolute value of A times this is absolute, times absolute value of K is then greater or equal to 1 times absolute value of A, of course. And that gives me absolute K, absolute A. And that's greater than or equal to absolute A. 1 times anything is still that value itself. Now at this point, let me see what happens. I'm naming this 4. From the second equation, that is equation 2, I know that absolute K times absolute A is equal to absolute B. So I'm going to fix that expression as B in the inequality named 4. So substituting, right? Substituting this into 4. This one, I'm substituting this value as absolute B into equation 4. So wherever I see this in equation 4, I put absolute B. What it means is that I'm going to get absolute B, that is absolute K times absolute A, which is absolute B, is greater than or equal to absolute A. Then when we switch by bringing A first, that will imply absolute A is less than or equal to absolute B. It's just simple. If 2 is greater than 1, then 1 is less than 2. Basically, that's the idea. So that's the proof. And that's it.